All right, number 15 is a very simple question. It says, can you give one example of power function and one non-example of power function? Well, I'm going to give you more than one example for each, for sure. Okay. Now, oops, sorry. I'm going to talk about what is power function. Okay. All right, power function. And then we also have not power function. Okay. Not power function. And while we're at it, I am also going to address a term that we talked about in class. It's called the constant of variation, which is like the coefficient, basically. Okay, coefficient. Okay. So what is a power function? Well, a power function is very straightforward. It's anything that is x to the power of something. Okay, say 4, any number that sits that's a real number. It doesn't matter if it's a positive or negative number. It doesn't matter if it's a fraction. Okay, as long as it is a number, a, a real number, we are happy. Okay, not only that, the number that sits in front of it, okay, that is the constant of variation right here. Okay, that must also be a real number. Okay, so we have the power and also the constant of variation, both being real numbers. Okay, so now a couple of things right here that for beginners, you might find these situations a bit intimidated. For example, if you have something like this, okay? If you have something like this, you're like, wait, hold on, is this a power function? Well, the key would be, can you express whatever that you see as x to a certain power? So it really draws the idea of, do you know that when you have a denominator for the x to the certain power, that's the same thing as the negative power, okay? And pi is just a number, by the way. Pi, it's a real number. It's just an irrational number, but it's a real number nonetheless. So we have it, okay? That's a power function, okay? Another one could be something like this. If you have maybe to the root of seventh root of, oh, sorry, x cube, okay? X cube, and then you have a seventh root on the outside. Is this a power function? We ask. And we say, well, can you write it as a power function? And we're like, yeah, sure. That's the same thing as x to the 3/7 power. So that is a power function. Okay. So don't be too intimidated with the decision right here. So again, your task, it's very simple in terms of identifying power functions. It's just that, are you able to write it as x to a certain power that is real, and yeah, just real numbers for both the coefficient and the power. So now let's talk about the non-power function. Okay, so well, for starter, if you have an imaginary, that's out. Okay, so that it's out. All right, if you have any kind of imaginary, whether it's in the coefficient or the power, it's out. Okay, now one thing that really tripped me a lot is that if I have something like this, okay, or anything I like, or maybe just these two, okay, just these two, x to the fourth plus x to the third power. Is this well, why isn't this a power function? Well, a power function is just a bare bone single thing, power function. Okay, nothing more, nothing less. If you have more than one power function in this function expression, like here, x to the fourth plus x cubed, what that means, you are not having a power function, and instead you are having a polynomial function. Okay, so if you see anything being added or subtracted, out. It's not. Okay, it's just not. Right, out of the question. Nope, whatsoever. Okay, And I think this is really the most bothering one because on one hand, you want to make an argument that wait, they're both power functions, but they're added together. So are they? Well, if you cannot write them as a single power function, it's out. It's totally out. Okay. What else? If you have something like this, whatever power functions that you have and plus or minus whatever number, okay, that's also a polynomial function. Okay, so again, power function is very simple. It's just that you have a coefficient, okay. It could be a number, it could be a pi, it could be something, but it must be a real number. And then you have x, and then you have to have a real number for the power. Now, I think there's one extra one that people might be tempted to debate, like this, okay? This is not a power function because power function is x to a certain power. This is not. This is an exponential function, okay? This is an exponential function, so do not get confused. So again, the bottom line, if you want to ask yourself, do I know power function? Then the question would be, well, can I write the simplest power function possible? And what confirms your knowledge would be, can I write some non-examples? If you could, wonderful. If you can write the non-examples that I have on the right-hand side in red, that would be super, super wonderful. Okay, so that's number 15.